This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today's discussion centers around an intriguing interactive physics simulation. 3 different liquids in pipe. It's a JavaScript applet designed to teach about fluid pressure. What initially drew you to this particular simulation?
The elegance of its simplicity. It tackles a fundamental concept, pressure equilibrium in fluids, using a visually engaging and easily understandable model. It's a perfect example of how interactive simulations can enhance learning.
Exactly. It's not just about showing the outcome, it lets students manipulate variables and see the direct impact. What are the key concepts this simulation effectively demonstrates?
Primarily, it showcases the relationship between pressure, density, and height in a fluid. Students can adjust the densities of 3 different liquids and observe how their levels change to achieve equilibrium, equal pressure at the bottom of the pipe.
And that equilibrium is the crucial point, isn't it? It's not just about the individual liquids, but their interaction. Let's delve deeper into the concept of pressure equilibrium. How does the simulation illustrate this principle?
The simulation visually represents how liquids of different densities settle to create equal pressure at the bottom of the interconnected pipe. This is a direct demonstration of hydrostatic pressure, where pressure increases with depth and density.
So the visual representation is key to understand the abstract concept of pressure equilibrium. It makes it tangible for students. The simulation highlights the relationship between density and liquid levels. Can you elaborate on that?
Absolutely. The simulation allows users to change the density of each liquid. They'll see that denser liquids settle lower, while less dense liquids rise higher, all while maintaining that equal pressure at the bottom. It's a powerful visual demonstration of a fundamental principle.
It's a great way to move beyond rote memorization and into true understanding. The interactive nature allows for experimentation and discovery. The simulation is designed for interactive learning. How does this approach benefit students?
Interactive learning allows students to actively participate in the learning process. They're not passive recipients of information, they're actively exploring and experimenting. This hands-on approach fosters deeper understanding and retention. Plus, the HTML5 and JavaScript implementation ensures broad accessibility across different devices and browsers.
And the embeddability feature makes it incredibly versatile for educators. It can easily be integrated into online courses and learning platforms. Let's talk about the simulation's controls and features. What functionalities are available to users?
The simulation includes standard controls like play, pause, and reset. Crucially, it features height and density tabs, allowing users to independently adjust the height and density of each liquid. This gives them fine-grained control over the experiment. There's also a full-screen toggle for a better viewing experience.
Those controls are essential for effective experimentation and observation. The ability to isolate variables is a significant advantage. The simulation credits several individuals. What does this tell us about the resource?
The credits highlight the expertise and collaboration involved in creating the simulation. It's not just a simple applet, it's a carefully designed educational tool built by experts in physics education. Furthermore, it's part of a larger collection of open educational resources, showcasing a commitment to sharing knowledge and promoting accessible learning.
That's a testament to the value placed on open educational resources and collaborative learning. What are some potential applications of this simulation in educational settings?
It's ideal for classroom demonstrations, interactive homework assignments, and online learning modules. Students can use it for self-paced learning, reinforcing their understanding of pressure and density. However, the missing sample learning goals, research, and video sections represent missed opportunities to enhance the educational value. More detailed documentation on the underlying physics would also be beneficial.
Indeed. Adding those elements would significantly improve the resource's pedagogical impact. It's a valuable tool, but it could be even better with more comprehensive supporting materials. The accompanying quiz and essay questions are designed to assess student understanding. How effective are these assessment tools?
The quiz provides a straightforward assessment of basic understanding, while the essay questions encourage deeper critical thinking and application of the concepts. This combination of assessment methods is effective in evaluating different levels of comprehension.
The glossary of key terms is a valuable addition. How does it contribute to the overall learning experience?
The glossary provides clear definitions of essential terms, ensuring that students have a solid understanding of the vocabulary used in the simulation and related concepts. This is crucial for effective communication and comprehension.
The FAQ section addresses common questions about the simulation and the broader collection of resources. What does this tell us about the design philosophy?
The FAQ section demonstrates a user-centered design approach. It anticipates common questions and provides clear, concise answers, making the resource more accessible and user-friendly. This proactive approach to addressing potential user concerns is commendable.
The simulation is licensed under a Creative Commons license. What are the implications of this?
The Creative Commons license ensures that the simulation is freely available for educational use, promoting open access to educational resources and fostering collaboration among educators. This aligns with the principles of open educational resources and supports broader access to quality learning materials.
How does this simulation compare to other physics simulations available on the platform?
While many simulations focus on specific aspects of physics, this one excels in its clear and concise demonstration of a fundamental principle. Its simplicity and interactive nature make it particularly effective for introductory level learning. Other simulations might be more complex or focus on more advanced topics, but this one shines in its targeted approach.
So in conclusion, the three different liquids in pipe simulation is a valuable tool for teaching fluid pressure. Its interactive nature, accessibility, and clear demonstration of key concepts make it a strong resource for educators and students alike. What are your final thoughts on its potential impact on physics education?
I believe simulations like this have the potential to revolutionize how we teach physics. By making abstract concepts tangible and interactive, we can foster deeper understanding and engagement among students. The open access nature of this resource further amplifies its potential impact.
That was a great discussion. Thank you for sharing your expertise.